Start recording. There we go. Dave, you got to remind me. Start recording.
Start
Okay.
recording.
All right. We are going to be doing something new as I pause for a moment. The start recording. We are going to be taking our monthly webinars and going into a new form of technology called YouTube, which is not something I typically do a lot of, but these monthly meetings and specifically the tech talks are going to be put on the BCA website, and I may actually be able to preview that while we're on this call. They're working on it. Last month's tech talk right now, so that's why starting recording is getting the audio and video linked up and recorded properly. So starting over, NCBC 2014, it is coming up. It is right here on your screen, May 19th to the 21st. On Monday, there's a golf outing, a charity BCA golf outing for scholarship funds. So please, you can click on that. It is in Hartford. There we go. It is so, why is it doing that? Just go home trying to pull up NCBC. There it is. Wrong click. Hartford, Connecticut, May 19th to the 21st. Agendas are laid out. There's going to be some really good speakers. One maybe okay speaker, which would be me. But another great session coming up. It's not too late. There's hotel rooms still available, I believe, right there. So it should be another really great conference and a fun time. So if you have not registered, now is the time to try to squeeze that in, as that's about a month away. So top priority NCBC 2014. We'll go back. The next thing I wanted to touch on is actually something I worked on personally, and that is what's called the NIBS, or the Department of Energy Commercial Workforce Credentialing Council, or the CWCC. And you'll follow me, bear with me for a moment, and I'll explain what all this is about. The Department of Energy has worked with the National Institute of Building Sciences, and what they have done is they have gone out and said we need to standardize certifications for, there's 4 of them they've been working on: Energy Manager, Energy Auditor, Operations Professional, and you notice this last one, Building Commissioning Professional. And what they are striving to do is determine the credentials and the skills and the attributes that a commissioning professional should have, in which they can then build curriculum to take a test, i.e. something like the CCP. And they are trying to standardize the industry. And this goes to a long-standing complaint that we've all shared, that the BCA has a certification, and University of Wisconsin-Madison has a certification, and ACG has a certification, yada, 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 and AEE has one, and there's like 7 or 8 of them. And they're all different, and the standards and the level of rigor and the criteria for each of them are different. So what has happened is the Department of Energy has stepped in. They've solicited NIBS to go ahead and conduct this. It is and you see some highlighting on the screen. That's because you can search for it under the NIBS website. It's called a JTA, or a Job Task Analysis. So if you were to go to the NIBS website or send me an email, I can send you the link to this. But what has happened, and that's why I said I personally am involved in this, I sat down with NIBS for 3 days. Along with about 14 of my closest dear friends in our industry, and I say that because we worked together so much for many hours in 3 days, but it was people from all over the industry, all different associations, and what we did is we came up with the skills and the tasks and the credentials that we thought were important for commissioning people to have. That task has been completed. The data has been crunched. Why am I talking about this? Because if you go to this NIBS website, there is a thing that says, please click here to access the study. The step they are in right now is called the validation study. They are taking what we did for 3 days and they've boiled it down into a study, and they are looking for input from commissioning professionals across the industry from all different associations. And literally it is a study to say, what are the things that are important? So for example, understanding building systems. Is that important, or is that somewhat important? Is that very important, or is that essential? And they kind of have these listings of items. So being able to do energy calculations might be another item, and you might say, well, okay, really understanding building systems is essential, but energy calculations is somewhat important, and you go through this study and you pick and choose. All of that to be said, this is where they're at in this process, is this validation study. And they are looking, and as an industry, we want them to get people to participate. Notice it does say it takes about 30 to 45 minutes. Because I was familiar with it and I participated, I was a little quicker, but I would say probably about 30 minutes is about realistic. So grab a sandwich, eat at your desk, and click through here. You can go to the NIBS website and you can put in JTA study in your search criteria in this green box, and you will be able to find this, and you'll see this announcement. It's important that we do this because this study and the output of the study will validate the work that we did for those 3 days, and it's what's going to then go out to the industry, go out to the BCA, go out to these other ASHRAE, ACG, etc. Go out to them and say, here are the things that the industry finds important in which you need to build your tests around. So now let's talk about BCA. The reason the reason I talk about that is the BCA is got as their #1 strategic plan, strategic goal, is to get their CCP to be certified through the ISO process, and I forget, Dave, is it the ASTM process? ANSI, I'm sorry.
ANSI?
Yeah, ANSI process. They are working, they've got that as their #1 priority. So they are looking to take that output of everything I just talked about with that NIBS study. They're going to take that, they're going to revamp the CCP with that curriculum based on the study and all that research, and they're going to work on getting that ANSI certified. That is a huge undertaking, both in work and financial. The ANSI certification is months long. Actually, it's over a year in the works. There are support people that we have to bring in, consultants, i.e. consultants, and we are talking $100,000 and up. I mean, I think the number is even closer to $200,000. So it is really important. We see that as in the BCA as a strategic mission, a strategic goal. So the reason I talk about that is you'll see down here the C-Note Club. Okay, it's the $100 club. And what I would say, and I am not a pastor, I don't get in front of people and ask for money, but the C-Note Club is been called to my duty to say, if you make your living doing commissioning, and basically it's part of your passion and part of what you do every day, and you believe in the BCA as the only association that is solely focused on commissioning, we are asking everyone to contribute $100 out of your pocket. I've done it. I've done it actually the past several years. Board members, we've done that a bunch of times. So, but now's the time. We've got to call people. We've got to ask them to task and say, we really need this. The money to get ANSI certified, like I said, is beyond what the budget was. We weren't really projecting this, but it's suddenly popped up as a really hot item, and we really see it as important for the BCA's future. So we're asking people to contribute. You can go to the C-Note Club on the website. You can add it to basically your shopping cart, and you can put it on the credit card and pay it that way. So it is really important for the BCA. We see that as a huge differentiator as well in getting the BCA recognized as a commissioning leader in the industry. And that's not to say that your company, if you want to look at some of the other sponsors, can't do that as well. But this is really on a personal note. This is, John Villani making his living, Dave Gubrud making his living, and writing a check. So we're trying to get as many people to write one of those checks as possible. And to be honest, we've done the numbers, and the treasurer of the BCA has done the numbers and said, if everybody chips in $100, we'd have this covered, no problem. So I won't belabor that anymore. The next thing on my sort of BCA news list is renewals. Just membership renewals. It is yearly, but what happens is usually you have your a little bit of grace period. Well, the grace period, I think, is like tax day. It just ran out. So as it says here, don't miss out. Renew your membership today. If you have not renewed, you will be getting one of those sorry, you've been terminated letters or emails from the BCA. But please renew. All of the chapter funds that we do everything with comes out of membership dollars. So your membership fees go both to the international, where they do everything that they're doing and cover the staff costs, as well as things that we do with the chapter. So renew your membership, please. The other thing is, I will throw out there, I know we've got different people on the call from out throughout the Central Chapter region. There is some planning right now for a 3-day training course that the BCA has already put together, covering retro commissioning, or if you will, existing building commissioning, and new construction commissioning. It's a 3-day training class course that's already put together. They can have someone come out and present. Usually it gets sponsored. There's a cost per student to do that. But that's a program that's been moving around the country and getting great reviews. So if you have, I'm going to be working here in Chicago with ComEd to try to get that pulled together for the fall. Since they have, and again, they call their program retro commissioning, so that's why I usually slip and not use the BCA term of existing building commissioning. But so I'm working with them to try to see if we can pull that together. But if you in your region have something and have connections with the program people and the utility people, or even a really big client, university, healthcare institution, etc., we're trying to use that as a outreach, as an education, as well as make a few dollars and at least cover the costs for that. So that is something that I want to highlight there. Dave, I'll reach out to you and say, is there anything else that we have not covered other than, I'll repeat, NCBC coming up?
I believe that, no, you covered the base as well, and certainly the NCBC is, if people have not attended that or whatever, it is a fantastic event. There's a couple of people from our office that's going. I unfortunately can't go there. I have a teaching obligation or whatever, but it's important, for our team to go there and to be with your peers, and the subject matter that gets discussed is top-notch.
Excellent, and I concur. I really, from the perspective of meeting your peers and talking about kind of leaders in the industry and best practices of what other people are doing, this is where to go. This is where I know I personally draw some inspiration out of NCBC and getting to talk to people that are fighting the fires just like we are every day. So I second that. I don't know. I've lost track of what one this is for me, but it's many. But with that, let's get rolling into the Tech Talk for today. And I am going to view a Sorry, slideshow from the beginning. There we go. All right, so Dave Guberud put something together on something that we all do a lot of, or many of us do a lot of, talk about VAV boxes. And before we start, if you have a question, I've got everyone muted, but hit the question. Okay. If you have a question, hit in your panel, your GoToWebinar panel, you can hit the question mark, and I'll be able to see that.
Thanks, John. I guess you guys can't see me, so you can't tell if I'm actually reading these slides or whatever, or if I'm going in, from memory here. But I guess, we come up with different topics, and, just to kind of, sometimes to be provocative, to ask questions and think about something. And one of the things we just kind of came up with here, we were talking about static pressure limits a while ago and free stats, but just another device, like we mentioned here, the VAV box. I mean, it is so simple yet so powerful. So next slide there, John. And as John mentioned or whatever, I think that the VAV box, out of everything quantity-wise, is certainly the largest single device that I think that we touch during the commissioning process, from construction verification right through the functional testing. And what I want to do is kind of just highlight some different aspects of it and some things that I see as potential, not necessarily gotchas, but just things to think about when we go to functional tests and even how these things operate alone or together. Next slide, sir.
And I'll give you the first gotcha, if I can do my spotlight, because these are Dave's slides. Don't ask me how or why, but we ended up with one job where this is the access store in the box, by the box manufacturer, and it was uninsulated. And it was a healthcare project where, and I'd say most projects, a lot of times in the summertime you'll get down to 55 degrees, and up in the plenum space it was warm enough that we were getting some condensation dripping out of that. So just check the manufacturer's access door that it's actually insulated. So
good call.
I'll chime in when I see things that jog the memory.
The VAV is, the base of control, and I'm kind of wanting to highlight these these four kind of main topics. Certainly the most important aspect we think of it is, temperature control, but it certainly does have, a big component with air changes, especially when we're dealing with healthcare and all that other fun stuff, and just the actual, cooling BTUs that we need to cool that space. Pressure relationships, when we're potentially dealing with return VAV boxes and exhaust VAV boxes, and then just occupancy and the mixed use of it, with maybe occupancy sensors, occupancy schedules, how they all mix together. Next slide. So maybe just going with the basics or whatever, and to spend a little bit of time here, I think virtually every VAV box, and these terms originally came from the old pneumatic control industry, but typically, but pressure independent, which is really that VAV box is reacting to the duct pressure in the within the duct system, and the command that's actually telling it to go between minimum and maximum. So it's the old antage or whatever of, you might have 2 inches of static pressure behind it, and your damper blade might be at the 45-degree position, blowing 400 CFM of air. Yet if we are maybe at 1 inch of static pressure, that damper might be full open or almost full open. Never really want it to be completely open, and still maintaining that same 400 CFM. And there's a whole probably myriad of things that we can talk about, even with the trim and respond devices and all of that, on how best to control static pressure to damper relationship. And then we have pressure dependent, which is really that damper position going between, a preset physical minimum of, we'll say, 30% to, 100%, strictly based on temperature or some other means. So it's not looking at we don't know what the actual outside or the air quantity would be because it would vary due to the static pressure behind it. So it truly is a position-sensitive device. And then other things just to contend with and whatever, and I think most VAV box manufacturers can handle shorter runs, but that straight length of duct in front of a VAV box, it does have importance. I couldn't dig up any slides of the ones that have the 90-degree bend right in front of the inlet, but I think we've all seen those. And other basics, most VAV boxes do have that reheat coil, and then there are the variations of a VAV box when we start adding fans to them, and not going to get into series or parallel fan powered boxes, but we have that choices also.
And what Dave was just talking about, he's talking about that straight length of ductwork right here, where I'm kind of let's see if we can see this from the inlet to the box this way. And what he was describing is make sure there's not an elbow like right here, because that will the air will sort of force itself to the outside of the curve or the turn, and you'll get more airflow on one side of the flow cross and less on the other, and it starts to get the readings get a little bit wacky, and you may not be actually getting the CFM that you think you're getting. So that's you should come to Chicago. We got lots of jobs where there's 90s and where they don't follow that manufacturer's guidelines. All right, hold on. There we go.
There we go. There we go. So, the temperature control. What I wrote here is take advantage of VAV CFM set points, the controller has to offer. And I probably could have got a mechanical drawings schedule, but so oftentimes, they'll just say what the VAV box cooling maximum is, which is, certainly that CFM quantity that's needed to cool off that space on in a design day condition. But the schedules might oftentimes just say minimum. And the question is sometimes is I don't want to say is it the right minimum, but there are so many other choices that could potentially be there that should really be investigated. And a lot of these things also are set points that your Johnson Controls, maybe your automated Logics, your Honeywells or whatever, they actually have these values already within their software. And if they don't have a number that there really truly should be, they actually operate at whatever default number is in there if that portion of the sequence ever gets activated. So it can make a VAV box sometimes do some crazy things. So some of them that I denoted here is the occupied ventilation minimum, the heating minimum, cooling maximum, which is probably what everyone would probably consider the most important device. Your unoccupied minimum, your morning warm-up maximum, and then something that some control people have, which is called like a standby minimum. So lots of things to consider.
And I'll chime in for a second here. I know one of the systems we worked on, you've got a cooling max, which the controls technician will enter in off the schedule. And if you don't put in a heating max, it just defaults to the cooling max. So if you said, Dave used 400 CFM, so if your cooling max is 400, then the heating max becomes 400. And what I would argue is we're commissioning folks, and one of the things we need to check is these set points, usually not so much on, let's say, the cooling side. Usually we just hit the CFM number. But we've definitely seen where when you've got 55 degrees going out of your air handler and then you go to your heating max and it matches the cooling max, there are times when that two-row or if it's a single row reheat coil is not enough to actually give you like an 80-degree discharge coming out of your diffuser. You go from 55, it heats it up to maybe 65. Well, to heat your space up, it's going to take a really long time. So I would argue, and I would say, we're commissioning folks that you should be doing tests in your functional test, or really more of an integrated systems test. We typically do this sort of after our functionals, where we'll actually swing the building and say, okay, go into heating mode, and then do some trending and take a look and see what spaces make sure that your spaces are able to actually warm up in 15 minutes, 30 minutes, something like that. If you've got a space that, hey, I've cranked the set point up and it's not getting there, okay, well then why? What's going on? It's a lot of times also, as Dave said, VAVs are a huge quantity. It's rare that you test every single one, and you're using some sampling strategy. So that's okay, but make sure you're doing trending on everything, and then you're able to pick up on that. Hey, this room over here is not really heating up. What's going on? And then you can go investigate. So watch the heating maximums. We've seen that be an issue.
And on that note or whatever, kind of I wrote here ventilation minimum and heating minimum, and typically it's driven by the room and code or whatever. And where I'm going with that is healthcare is more often that minimum air change rate is the driving factor, and that's oftentimes higher than what a heating minimum might be. Whereas in an office condition, excuse me, the ventilation minimum might actually be a lower number than what the heating minimum would be to keep the air coming out of the VAV box from being, both exceedingly hot where it would potentially stick on the ceiling, or just the proper air quantity. And if those numbers are both the same in an office building, you're not taking advantage of some potential energy savings. Because if your heating minimum is higher than your ventilation minimum, that's a little bit more fan horsepower and likely even more of the promotion of maybe some reheat. So if you add that ventilation minimum down lower, it's likely that the room would coast, maybe not needing the reheat, and also allowing the fan to back off and saving some energy.
And Dave, that's a great plug. If you want to talk air changes per hour, come to NCBC for healthcare, because I'm doing a session on operating rooms and critical environment rooms within healthcare and air changes per hour, and including occupied and unoccupied. The other thing is, if you're just doing office building stuff, evaluate if you can get rid of ventilation off hours, because you probably don't need ventilation. And you can also go to a minimum CFM, heating, cooling minimum, go to 0. If the space is within a certain temperature range, you can take the conference room I'm sitting in. It has no exterior windows, so this would be a perfect room at night. You just go to 0. So you can play around with things like that.
Which, going back to the almost, John and I love this kind of conversation. We don't rehearse before these things, and we kind of go back and forth, and the things that I think of, he thinks of, and vice versa. And I guess this is kind of segueing to what John mentions. The VAV set points, their importance kind of sometimes varies with the type of buildings you have. I mean, if you do have a lab where an air handling unit runs 24/7 versus a building, an office building that's scheduled or whatever, there's the possibility that some of these set points or whatever and what they're set at are, their significance is either lessened or heightened depending on the building. Next slide, if you got a second, John.
Yep.
And so like in a lab, and I just am throwing out a couple of examples here. When the space is unoccupied, and I guess in the lab area I would kind of base that occupancy more, it can be literally on a schedule, but oftentimes it's also impacted by an occupancy sensor. But, where I'm going with that is that when you are unoccupied, you're saying that there's no people in there, you're still having to provide the exhaust for your lab hoods and things that do need to run, but you can actually have the ability to cut down some of the airflow rates. So your offset would still be the same. Your lab would be a negative room, but being able to reduce some of that air quantity again has some savings on some horsepower. Corridors though, which are typically the makeup air for those labs, well, that makeup air is usually still the same amount of makeup air whether it is day or night. So those typically run the same. But if there are offices that are potentially off of the same air handling unit system, designers get pretty creative by maybe putting in a small return fan system for some of the VAVs that might actually have return. Those areas you could completely close off using the example that John just mentioned of his conference room. If there's nobody there at night or even during the day, maybe based on an occupancy sensor, let's close that VAV box off completely because there's nobody in there.
And just a word of caution, because a lot of times the reality is the commissioning guys, us, we are the ones at the end of the job figuring this stuff out, and we're making some suggestions. So we're working on a project right now where we're saying after unoccupied hours begin, we can, and the temperature within the spaces are, anywhere between, we'll say 55 and 85. We can bring the boxes and go to zero. There's nobody there, no occupancy, so as long as the building's within a reasonable tolerance of temperature, you can close the boxes off. The caution is there's a common toilet exhaust, and there's a multi-floor building, so we're saying certain floors will be unoccupied, other floors will be occupied. So when you unoccupy a floor, make sure you leave a little air in there. Look at your exhausts for things like the toilet room, which is still going to be running. We've got some electrical rooms that have exhausts, so they use actually the space air to kind of pull through the room to mitigate the heat from electrical rooms and IT rooms, etc. So make sure you kind of take those other spaces into account, and that way you're keeping your building slightly and your floor slightly pressurized, because you can also you can go too far and shut too many boxes off and start getting some weird pressurization issues in your building. So even in a simple office building, just be cognizant of that.
Whereas in VAVs, possibly, or in an office environment, you got to consider what's also there. If there's fin tube radiation, typically in a typical sequence of operation during unoccupied, we're talking about cycling the air handling unit at night. But we have to still remember some of this old school stuff, that if there's fin tube radiation, there's likely not a need to have to cycle the fan because our perimeter is being covered by the radiation, and the interior spaces, in theory, really shouldn't be losing any heat anyways, except maybe if we're talking about the top floor. But other aspects of this, though, is if you do have a building that's scheduled, some areas scheduled, some not, keeping that VAV damper closed, or VAV unoccupied minimum set at 0, the box will actually go closed and not potentially subcool that space. And though I wrote it there in smaller font, I wrote there, a number other than 0 will make the box wide open when off. And where I'm going with that, it kind of goes back to that pressure independent that I mentioned on a few slides back, that that VAV box, if it's looking to maintain 200 CFM, it's using its feedback to get to that, and the only way it knows how to get there is by continually opening its damper. So if you would by chance have an unoccupied minimum of 100 CFM and your fan is in fact off, that damper blade would go full open when the fan is off. Now that's not necessarily a bad thing, because if the fan does start, it's starting against not a bunch of back pressure against closed dampers, and the boxes would react. So it's not necessarily a bad thing, but as John kind of mentioned, it's us commissioning people that I think that are really looking at this big picture wise. The control contractor is, they're literally looking at it, just as a particular device a lot of times, and it seems to be few and far between when you find a control contractor that thinks about it again as the big picture.
And that touches on one of my things I harp on is, as a commissioning guy, you need to know how the VFDs that are controlling the air handlers are set up and the parameters. So there's something called the ramp-up speed, acceleration and deceleration, and that's how fast the fan will go. Most Seasoned controls guys will know to put something in there to make sure the fan doesn't ramp up too quickly. But there's still a lot of junior guys out there programming and setting those things up, and it's not uncommon that you'll have, when you test occupied or unoccupied back to occupied, every now and then you're going to find this a fan system that just sounds like it's a drag strip, and this thing's just going all out as fast as it can get there. Well, that's because all the boxes are open. They're wide open, as Dave's talking about. The static is under set point, right, because it's 0, and it's trying to get to that 2 inches, 3 inches, whatever set point it's trying to reach, and the fan just screams trying to get there. Again, commissioning guys, we need to be the technical guys that say, wait a second, whoa, have you set that acceleration, deceleration rate, so how fast it can do that? I can't tell you what speed it needs to be, but it's not 0 to 60, in a minute. You can take a little bit longer than that and let the fan slowly build up so you're not jamming all that air down the ductwork.
Space temperature set points. There are many to choose from. Occupied heating, unoccupied, both heating and cooling, unoccupied heating and cooling, standby. And let's not forget about the set point adjustment itself. So I kind of just made a little slides that'll go on top of each other here, John, if you want to go to the next one. And so the top two or whatever, I'm not a PowerPoint expert or whatever, but let's use an example of our heating occupied set point is 71, our cooling occupied set point is 73. And where I was writing there, the narrow dead band, the closer you can keep your heating and cooling set points together, does equate typically to more comfort because the occupants don't feel as much change in temperature before the heating or cooling would actually start modulating or kicking in. But the wider you can make that dead band, is typically the more energy saved. So again, that's something that's hard for us just to choose those numbers right out of the box. When we're working with owners, we're trying to find a good number, but so many times when we're starting things up, right, and functionally testing, the occupants, the potential complainers, are not even in the building. But for my example here, an unoccupied heating set point of 62 and 82, those unoccupied set points, you actually have to be cautious of those. Sometimes you might just find a cavalier number that a designer might put in saying unoccupied set point of 55 or something like that, or 95. And the question of that is, would your building even be able to recover in time, on a heating aspect or a cooling aspect by occupied hours if, in fact, you let the building get that cold. Now, typically buildings are a lot tighter than that, but, I think everyone has found those leakers out there. And then a standby set point, which I'll get to in a moment here, which kind of widens the normal occupied set point of like 70 and 74. And standby is something everyone has different terms. I'm going to use that term mainly as a Johnson control term, though other people call it different things. But that's mainly used when an occupancy sensor is involved. So something during the day hours and nobody's in the space, let's kill that box, let the minimum go to 0, widen the set point a little bit, try to get some energy conservation out of it. So if you can go to the next slide, John.
Yep, and I think Dave's just said something real quick. Unoccupied, 62, 82, and he mentioned, can you recover? One word of caution, and this is coming from a guy that worked for a controls contractor, a controls manufacturer. Optimum start, optimum stop, and really what we're talking about is the optimum start. Almost every controls company will say they have that program logic, but as we all know, it really comes down to the technician that's working on your job. If you're letting your unoccupied go to like 82 or 90 or whatever temperature, or on the other side really cold, that optimum start's really important. Make sure you do trending on that, because I would say it's few and far between where I actually see that really working. And a lot of times, even if they do say it's working, it takes a little time for the system to learn the building and the mass and the thermal properties of the building to get it dialed in. So just word of caution, those numbers, that may be something that you start a little narrower and then over time can kind of expand out.
So, so I guess this is just a little more explanation of the slide prior there, John, so you can flip to the next slide. And then what I wrote in here is that, what set point adjustment does is it just really takes all of those numbers that we mentioned before, occupied, unoccupied, standby, and it shifts the whole number up and down. So there's a number of things to consider, and dead bands and whatever. So, with so many numbers, sometimes when you're working with the owner and trying to get an understanding of trying to give him an understanding of how it works, it can get to be a little bit confusing. So this is showing the effect if we're changing the set point up by 3 degrees, and the next set point shows us going down by 3 degrees.
One of my favorite spec things to review is when you are looking at the spec for a job, for let's say a new construction commissioning, is should the thermostat have a display where you can see the actual temperature and actual set point. We'll pick on Johnson. I know they've got one with a round dial that you can actually turn that has no display, so you don't really know it. Have I made it +3, +1, +2, etc. Some of them are a little harder to figure out, and owners typically know what they want. At least the facilities guys within the organization. So great thing to review in your specifications. Oh, here's your -3.
Yep, that's the -3, and then next slide, John.
Yeah.
And see, this is where we're going with that. It's what's numbers even displayed on that. There's all sorts of thoughts on there. Potentially less is more. Just a dial showing warmer, cooler, showing a number. I mean, sometimes these numbers can be too much information, and it is definitely something that you have to work with the owner and decide what the best choice for them.
What I would say is, you look at the thermostat on the right, we've had to do, and we'll typically try to do what we call end user training, which is for the actual, as Dave says, the complainers, the people in the space. And some of these thermostats are not very intuitive, meaning you walk up to it, you hit a button, and on one of them we did training on, the first thing it does is it displays the temperature of the space. Then you have to hit, I think, another button a second time, and then it will flash the set point. And then you got to hit it like a third time, and that'll actually get it to so you can actually go to the change set point mode. So just keep in mind, we're the experts. We're the ones making this stuff work at the end. So a lot of times, including a 15-minute, a couple 15-minute, as you're walking around, you get the PM to coordinate this, and you can do a couple of these user trainings and really help mitigate some of the complaints.
And this is just kind of putting it all together, and it might not be, it kind of goes back to my old trend presentation. Sometimes it's great when things overlap, but sometimes it makes it also a little more difficult to see. So if you can go to the next slide, John, the top aspect or whatever, showing a little different Y scale, is actually showing the widening out of the running in the standby condition. And when it's running in the standby condition, the air volume is dropping from its typical 175 CFM down to 50. And in this instance, the owner didn't want their box to go completely closed, taking in some toilet exhaust concerns that I think John mentioned earlier. But it's actually showing how the VAV box is reacting, and actually, I'll say, just by a fluke over there at the, after the 1 p.m., you could just actually start seeing that the room actually had a demand and started creeping its way up, and it's good to see that both set point and the actual are the same number. So next slide when you got a moment. So this is, again, maybe this, I took that information and place it just kind of in a little spreadsheet, just pushing in my own numbers there, and the greenish line, if you will, is actually showing what the VAV set point is, and then the red and the blue are the heating and cooling set point, and you can see how it's potentially varying between its occupied, unoccupied, standby, and the normal occupied. And John, if you go to the next slide, I broke the graph about, again, to make it a little more pronounced. And that first big push there that we see right when it goes to occupied, that's actually when morning warm-up kind of kicks into place, and that's actually when maybe your air handling unit is telling the coil to go wide open and the damper to go closed, just to dump as much heat as possible to warm up the space quicker. And then the rest of the graphic is just showing how the space is corresponding to both the occupancy sensor, and then later in the evening, which is kind of the line on the far right, is we have a person that actually came into the room during unoccupied hours, and then the VAV then reacted again. Next. So, like I mentioned here, this is an educated owner who didn't want to close off the VAV box completely to standby. He wanted to make sure that this building actually has, the capability. It's an educational building in a university where there might not be virtually anybody in the building, or one or two people. So, we just wanted to make sure that we were moving enough air for that toilet exhaust. Next frame. So occupancy schedule, like we mentioned, the building, the floor, the group, we work with our owners also of trying to find out the best way to schedule their building. And then the utilization, which we see more and more so, of occupancy sensors, and if and where they can be used. And I guess next slide, John, we certainly have just the simple application where it's a single VAV box to a single room, seminar room, conference room, where if there is nobody in that room, we can just take full advantage of closing the box off. Now, during the day, I would recommend using kind of these standby set points, because you do want that room to kind of get preheated or pre-cooled in the morning, because if there is a conference or a meeting, you don't want to have that room having to, need an hour to recover from being either warm or hot for a 1-hour meeting. You want it to be able to respond quite quickly. The next slide is, one VAV box serving 3 rooms. So in this condition, you really need to have an occupancy sensor in each room, wired in parallel, typically, to be the input of the VAV box, so that if any one of those 3 occupants are in that space, then that VAV box would inherently go to occupied. Now, we all have that concern, and maybe, I don't know if that's where John has his red dot there for a reason. You certainly still have to contend with, and this is just the nature of the beast, that it could be the person in the far left office is the person that's entering. The person in the right office where the thermostat is still unoccupied. So it's not the best of both worlds, but it's designed and built to budget.
And yeah, that's why I was highlighting that. I know I done a lot of university work, and this is sort of their standard, about 3 to 4 offices per box, just to keep the costs down. And we'll do some education. We'll even give like the floor manager a little layout, an HVAC layout, and we'll have it color coded up or highlighted. So, and we'll literally do, again, when we're doing that thermostat training, we'll say, be friendly with your peers, because the reality is, only 1 out of every 3 of you actually has control of the temperature. So you guys got to all get along and work together. So exactly why I was highlighting that.
And I wrote on this next slide here, I wrote,
maybe. There we go. There you go, the color coding.
Occupancy sensor crazy, and where I'm going with this, and might not be the easiest to read or whatever, but this is one big common space that actually has, we'll exclude the little corner office, but it actually has 3 variable air volume boxes with return boxes serving this one common space. And if we go to the next slide, John, what had to be taken into consideration is the lighting controls. And where I'm going with that is that as soon as someone were to enter from, I'll say, the bottom middle there, and if you were to look at the lighting controls, that one room occupancy sensor where its dot was just on, that actually flips on all of the lighting.
Right there.
What they didn't want to have happen, which you would think, is they didn't want to have the large office area becoming a more or less a discotheque with half the lighting maybe being on and half the lighting being off. So that same concern, though, we brought up to everyone's attention is on the variable air volume side, is the VAV boxes, which there are 3, they can be controlled separately off of their same thermostat. We can go on a whole sidebar story of if they should all be adjustable or if we should work with master-slave, but they should all respond to these common occupancy sensors, so make all of them occupied, and not to have, say, the box on the exterior being occupied because someone's working in the corner and, on the upper right-hand corner there, where someone else might not be working in the other corner, and that space could go cold. So it's something that we were working with the controls contractor, and we got that set up, which we believed correctly. So I don't know, next slide, John. I don't know if I have a little pop-up on this. Oh, so again, just going back to this is kind of just re-showing the HVAC and multiple VAVs on one main lighting zone. We were thinking in this instance it really should be controlled as one lighting zone and not having those 3 VAVs operate off of just an occupancy sensor that might be going. And then what I wrote there also, what are the possibilities of fighting set points? And that's another thing to consider. If each set point, room thermostat, if you go to the next page, it shows better, John. Each one of those light blue stars are from that common space. We thought they were reasonable locations for the room sensors, but if they were all set differently, there could be some serious fighting going on between heating and cooling, and that's the last thing that you want. You kind of want the spaces to kind of work in concert with each other. Next slide, John. And I see we're running shorter on our time there. So I just want to talk a little bit about pressure relationships in the return or exhaust VAV boxes. We're certainly seeing a whole lot more of these out there, and they're out there to help maintain the pressure relationship. Whether it's a neutral space, a positive space, negative space, you can do virtually anything with these. And I think it's been both a control blessing to get kind of the pressure relationships, but it's also been, I think, a preventative maintenance curse on a lot of owners. And if we go to the next slide, and I guess maybe I'll go to this question, should return exhaust VAV boxes track, the supply CFM set point or the supply CFM actual? And we are, the advocators that it really needs to the returner to the exhaust should really be working off of tracking the supply CFM actual. Because if it's controlling off of the set point and something is aloof with the set point, then the return box is still trying to follow that number, the pressure relationship could be completely shot. But if you do actually follow the actual value, that return or exhaust box is going to do as best as job possible to still maintain the proper offset, whether that might be neutral, positive, or negative. Next slide. But as I mentioned before, these return and exhaust VAV boxes oftentimes need a lot more preventative maintenance because on the return side, we're not near as filtered as we are on the supply side. So there is lint and dust buildup on these velocity pickups, which do greatly affect their reading as they get dirty. So we have been making sure when we're involved on design side reviews, or even if we get involved on a project late that has return boxes, we're making sure that there are these, the probes or the velocity pickups are removable. And I wrote their orifice plate type. You know, a couple of manufacturers, I believe, make their velocity ring plus an orifice plate, and that is not, doesn't seem to be near as problematic of maintaining accuracy over time. But, you know, that's just kind of a personal preference thing.
And I'll just share that we're working on a university project in a lab building where we found major issues with exactly that on the labs and on the return side or exhaust side, and we've been working with the controls contractor to actually, you know, kind of lock the damper in place, disconnect the tubes, and then blow some low pressure but compressed air through the velocity and the static ports for the flow cross to basically blow dirt out and clean those things, because they're not removable. There's no way to get into them without, you know, cutting a hole in the ductwork, etc. And we've been finding that, you know, successful. But great point, Dave.
Couple more slides to go. We're almost done here, guys. So I just said we don't have time, but, you know, maybe down the road we could get into these kind of topics also, and that's where we're going here. You know, there's still the whole aspect of carbon dioxide demand reset on VAV boxes. There's a lot of way cool, fun things you can do with that. You know, actually people's software or whatever actually kind of modulating the, you know, the reheat valve, not just based on, you know, the thermostat calling for heat, but actually having a software limit to keep the reheat valve from actually discharging too hot of air, because, you know, the hotter the air, the more apt it's going to stick to the ceiling and not drop down into the space. Next couple slides, John, there. Just another little thing or whatever, I guess, you know, there's the Venturi type of valves or whatever, and, you know, some manufacturers are different than others, but, you know, there are some out there that, you know, the CFM readings that you're reading back as a feedback is actually a damper position, you know, how it's, where it is on the shaft and the spring, and it's not really the actual airflow. I mean, if something got stuck, or if there was a fire damper or fire smoke damper installed in front of it or behind it, really knocking off flow, and yet it shows it's reading air, you know, it's not, but that's just where it's going from the damper feedback. And what other things do I have there? And then other things to consider, you know, if your sequence is stated this simple, you will receive that simplicity. And this is just an instance of, you know, it does serve the purpose basically, but as I think we have discussed here, these devices can do so much more. It can save, it's there to help save energy, and I believe, you know, really every automation company out there can do all of this, but it really takes people such as ourselves looking out for the owner's best interests to actually push them to make them utilize all of these feature sets that they have within their software. If they're not kind of reminded to do that, they just kind of blow by it, is kind of what we oftentimes see. Last couple things, if hired early, you know, design review is really important. But if we're not hired early, you know, just during the construction phase, you know, I think everyone's using this term now, and I guess we'll just, you know, the controls page turn is such an important thing to get everybody around the table to actually say, you know, what people said they were going to do in a shop drawing review, to actually have everyone from the control contractor, the designer, the owner, the maintenance staff, ourselves leading the conversation, saying, okay, everyone's saying they're doing this in writing, but I want to hear out of your mouth what you're really going to do, because typically what they're really going to do does not match necessarily the words in that sequence of operation. And lastly, maybe
rarely ever.
Rarely ever. And then maybe putting a bow around what John mentioned earlier. You know, functional testing. You know, let the controls do the work on your benchmarks. You know, if there's 5 or 6 different potential sequences that designer puts out there of these VAV boxes, you know, thoroughly go through those 5 separate sequences on those different VAV boxes and let the controls actually make it function. Do not use overrides. The only time that we actually see the benefit of using overrides is that after you've kind of proved the solidness of the software, and then after that they're using it in a cookie cutter fashion for other programs, then I think you can utilize the overrides to your favor. But for the benchmark of each program, I think you really need to look at that and let the software do the work to make it function.
And to chime on that, a couple of examples, real life, kind of how to do it. I mean, one thing we'll do if you got a new space, it's not occupied yet, you know what, and you're in the middle of functional testing, leave all the rooms, lower all the set points. So we'll walk out of the job that day, or we're assuming that everything's working, cooling, heating, BAS is running, lower all the set points to, you know, if the set point's 72 plus or minus 3 or 4, whatever it is, you know, lower it down as low as you can. Leave the building, go home that night, you know, so the spaces are going to be shooting for like 67. Get in the next morning and crank them all up and go to, you know, as high as it'll go. So let's say 75, 76, and then have your trending going. So you can actually see and say, okay, I know I'm way, you know, I went from cold to warm. How are those reheats doing? Are we able to get heat into the space? And that's kind of extreme, but, you know, when you look at that an hour, 2 hours later, you're going to be able to find out what are the rooms that aren't getting there. What are the rooms that haven't moved off of that, and they're you know, half a degree warmer than they were. After 2 hours, you know, you should be able to see some good movement in temperature. Maybe not all the way up, but and that's again no overrides. That's just kind of swinging the building, and we'll do that both ways. You know, from warm to cool. The other thing I wanted to chime in, really important. Dave's calling it a control page turn. There's two things that we do, and maybe use a little different terminology. Early in the project, we'll do what we call a controls integration meeting, and that's kind of the review of the submittal. But at a point where we can get the controls guy to get the technician there who's going to do the programming, it's still usually earlier on. That's also a point where we'll talk about integrations to other things like fire alarm. But at the point that the tech is going to start programming, so this is sort of near the mid to 3/4 of the way into the job when the tech is actually going to start programming, we'll have another meeting, and really, really important, get the balancer there. One of the biggest problems we've seen lately with all of this, and specifically the AV boxes, is static pressure reset. And you need to find a set point for your systems, a high set point, which the balancers have always done. Crank all the boxes open, find out what our static set point needs to be. But you also need to find the low end for static pressure reset. Drive all the boxes to minimum. What's the low set point we need to have? And the balancers have not adopted to what's going on with controls yet. And these guys come in, they do their, I did my balancing, I did the typical, and you're like, no, you only found one of the 2 set points we actually need. So it's really important that, and to be honest, I think as an industry, I don't think anyone's really got a grasp of that. We're starting as an idea for our design projects to try to put in commissioning and balancer notes in our sequences of operations as a designer, so they understand what some of those set points are and what some of the balancing criteria are they need to do. But I think really us commissioning folks are really the guys to hold the hands to make sure we get those parameters determined. And
leave it. That's all, folks. I'm never very good at that, but I'm hoping you found some of this information useful. You know, during the course of time, you know, we could maybe, you know, get into things in more detail, and probably even more importantly for you guys listening or whatever. I mean, if there's things that you actually have an interest in, or something you want to study or discuss even, you know, more so, you know, John and I would love to co-present with you guys and whatever, and to go out there and, you know, again, you know, share the knowledge that we have, and just to help reinforce, you know, our profession.
And I think, Dave, I think we got not so. Just hold on. Let me hold off on. Let me cut you off for 1 second. Next month is NCBC, so we will not be having a monthly webinar. But the following month, in June, we have one of our Central Chapter members. I believe, if I have the information correct, Aubrey Swift is going to be talking about building envelope commissioning. So
Right.
again, one of our members talking about a subject they're intimately familiar with and sharing that with the rest of you. So I commend and appreciate that effort. That's coming up in June, and certainly building envelope commissioning is a hot thing that's becoming much more commonplace. So I commend Aubrey for doing that and appreciate someone stepping in. So yes, to Dave's point, if you have something, share it.
Absolutely. You guys might be getting bored of just John and I's voices. So that's all I have, John. I don't know if you wanted any closing remarks.
I will say thank you for joining us on this chapter call, and I hope to see you in Hartford, Connecticut, NCBC 2014. That's all, folks. Thanks, everyone.
So long, John.
Take care, Dave.